Let's dive right into this explainer because today we are dismantling a massive childhood lie. We've literally all been told this one. Picture a camel out there traversing the sand dunes. What is actually inside that iconic hump? Well, if you immediately thought water, you're definitely in the vast majority, but you are also entirely wrong. It's a total myth. So let's just jump in and uncover what an absolute biological marvel the camel actually is. But before we reveal the real truth about that hump, we kind of have to understand the environment this animal operates in, right? Because the stakes are just brutal. Think about this for a second. A camel can keep walking, working, and surviving for up to 40 days without a single drop of water. 40 days! And we aren't talking about a mild, breezy climate here. This is an environment where the heat regularly hits a blistering 50 degrees Celsius, all while they're endlessly walking on burning desert sand. These conditions aren't just difficult, they are incredibly lethal. Which naturally brings us to the ultimate question, right? It's the puzzle that has confused so many of us since we were kids. If that hump doesn't act as some giant built-in water balloon or a liquid canteen, how on earth does the camel survive this extreme 40-day gauntlet of heat and complete dehydration? Well, here's the reality check, and it really comes down to just one number, 35. The camel's hump actually contains approximately 35 kilograms of pure fat. Yep, fat. Not a single drop of liquid water is sloshing around in there. The hump is basically this massive, highly concentrated mound of biological tissue, and its entire purpose is just storing fat reserves for the absolute darkest, driest days of the desert journey. So, the crucial point is, how does this incredible reserve actually function? Well, it essentially acts as an internal factory. Step 1, deep in the desert, food and water become dangerously scarce. Step 2, the camel's body signals for help, and that 35 kilograms of pure fat begins to burn for energy. But it's in step 3 where the real magic happens. As that fat burns, there's this complex chemical reaction that takes place inside the camel's body, and it literally creates water internally. So it isn't storing water, it's manufacturing its own hydration, just through the chemical breakdown of solid fat tissue. It's a brilliant biological engine. Now, what's really interesting about this is that you don't even need a biology degree to know when this internal factory is running, because you can literally see the evidence from the outside. When the fat store is completely full, a healthy camel's hump stands perfectly straight and upright. It looks super firm, but as those long days in the desert drag on, and that 35 kilograms of fat is slowly burned away to create energy and internal water, the hump deflates. The fat is depleted, and the skin and tissue just hang, or dramatically sag right to one side. It's literally a visual fuel gauge, telling you exactly how much energy the camel has left in the tank. But eventually, right, the grueling drought ends. The camel finally reaches an oasis, or maybe a water trough. And when they do hit water, we transition from this story of incredible endurance to what is absolutely the ultimate hydration feat in the entire animal kingdom. 200. I just want to take a brief pause here and let that massive number sink in. 200 liters of water. That is how much a camel can drink in a single sitting once it finally secures a water source. Think about how many standard water bottles that equates to. It's like hundreds of them. It's an absolutely astronomical volume for any living creature to take in all at once. But honestly, the sheer volume isn't even the most mind-blowing part of this whole feat. It's the speed. 3. They don't just, sip those 200 liters slowly over the course of a relaxing afternoon. No way. They consume that massive, heavy amount of water in just 3 minutes. It's this torrential, rapid intake that totally defies belief. Which, of course, naturally leads us to ask this absolutely critical question. Why doesn't this rapid and massive water intake just kill them? Because make no mistake, doing that is deadly. If any other animal, and yeah, that definitely includes us humans, tried to drink that much water that insanely fast, the sudden influx of liquid into the bloodstream would be catastrophic. Our blood would thin out incredibly fast, our organs would be totally overwhelmed, and the heart would literally just stop functioning. It should, by all accounts, be a fatal overdose of water. And this brilliantly illustrates the camel's most hidden survival secret. You see, most animals, humans included, have round red blood cells. Under massive rapid hydration, those round cells absorb the sudden rush of water, they swell up, and eventually they just burst like overfilled water balloons. And that is exactly what causes the heart failure. But camels, they evolved with oval-shaped red blood cells. Because they're elongated and oval, these unique little cells can stretch and expand safely.
They can accommodate that massive rush of 200 liters of water in just 3 minutes without bursting. They just stretch instead of popping. So to wrap this all up, our source material perfectly states the camel is not just the king of the desert, but its entire body is a masterpiece of engineering. I mean, from an internal chemical factory that turns a sagging hump of solid fat into life-saving water, to oval red blood cells that completely prevent explosive hydration, the camel is just flawlessly built for the harshest environment on Earth. We've basically spent our whole lives believing this simple myth about a water-filled hump, and we completely miss the staggering scientific reality. Which really leaves us with one final provocative thought. If we were so deeply, totally wrong about the camel, what other deeply ingrained animal myths are you completely sure of right now that might be entirely false? Thanks for joining me for this explainer. Stay curious, and I'll catch you on the next one.